Okay, now what are the applications of hydrogen bonding? Where we apply this hydrogen bonding concept? There are so many applications of hydrogen bonding. So I will tell you where you have to apply the concept of hydrogen bonding. So the first concept to apply the hydrogen bonding, you know, every molecule have a definite boiling point or melting point. Those molecules which can form hydrogen bonding, they have always high boiling point. For example, if you consider HF molecule, HCl molecule, HBr molecule, HI molecule, I have considered 4 molecules: hydrogen fluoride, hydrogen chloride, hydrogen bromide and hydrogen iodide. If you want to compare on their boiling point, see, boiling point mainly depends on the mass of the compound. If the mass of the compound is more, boiling point you will get more. As you know, here hydrogen is same, difference is halogen, fluorine, chlorine, bromine and iodine. And among the halogen, iodine have maximum mass, then bromine, then chlorine, then fluorine. I mean, hydrogen iodide have maximum mass, then hydrogen bromide, then hydrogen chloride, then hydrogen fluoride. So according to mass concept, hydrogen iodide should have maximum boiling point, then hydrogen bromide, then hydrogen chloride, then HF. So since boiling point depends on mass, so since the mass of hydrogen iodide is maximum, so hydrogen iodide should have maximum boiling point. But it is found that HF exceptionally, although its mass is less, but exceptionally its boiling point is found to be higher. Why? Due to formation of hydrogen bonding. As you know, HF, when you take HF molecule, due to polar character, I mean due to formation of delta plus delta minus, due to electronegativity difference, they can form hydrogen bonding between the molecules. When hydrogen bond is formed between molecules, then what happens? Molecular association takes place. I mean molecules get associated with each other. And when the molecule get associated, then what happens? The mass of the compound, the overall mass of the compound going on increasing. And that is why those molecules which produce intermolecular hydrogen bonding, they have always higher boiling point. And that is why exceptionally, although its mass is very less, exceptionally hydrogen chloride have maximum boiling point due to formation of intermolecular hydrogen bonding. So this is one of the application of hydrogen bonding. If you want to find out the boiling point, then hydrogen bonding is one of the factor. You know what is the boiling point of water? 100 degrees Celsius. Why the boiling point of water is high? It is due to formation of hydrogen bonding. As you know, water molecule can form intermolecular hydrogen bonding, and due to formation of intermolecular hydrogen bonding, they get associated with each other. I mean number of molecules get associated, due to which the mass of the compound going on increasing, overall mass increases, and that's why boiling point also increases. So to find out boiling point, hydrogen bonding is one of the factor. Secondly, another application, as you know about periodic table. Group 16 contain oxygen, sulfur, selenium, like this, this type of elements are present. And group 16 elements contain 6 electrons in their valence shell. And due to presence of 6 electrons, their valence is 2. And that is why they are always combined with 2 elements. For example, when oxygen combines with hydrogen, it produces H2O. It combines with 2 hydrogen because its valence is 2. Similarly, when sulfur is combined with hydrogen, it produces H2S. Sulfur combined with 2 hydrogen atom. See, oxygen and sulfur, they belongs to similar group, and that is why their properties are same. And that is why oxygen produce H2O, sulfur produce H2S. This is called water, this is called hydrogen sulfide. But do you know one difference? Water normally exists as liquid, but at room temperature, H2S exists as gas. So if the question asked, although oxygen, sulfur, they are present in similar group, although oxygen and sulfur have similar property, why water exists as liquid H2S exists as gas. If you want to explain this question, then also you can apply the concept of hydrogen bonding. How? As you know, water H2O, oxygen delta minus, hydrogen delta plus, it is a polar molecule. This is another H2O, hydrogen delta plus, oxygen delta minus. See, this is negative and the negative always attract the positive. That's why hydrogen should be this side, and that's why I have drawn like this. So some hydrogen bonding is formed in between them. But H2S, yes, sulfur is electronegative. It also can form delta plus delta minus. This is delta minus, and this is another H2S, delta minus, delta plus, but it cannot form hydrogen bonding. Why? Due to large size of sulfur. Only 3 elements can form hydrogen bonding, and they are oxygen, nitrogen and fluorine. Here, due to presence of sulfur, it cannot form hydrogen bonding. Now I want to explain about this question. You know, there are 3 states of matter: solid, liquid and gas. You know the difference between these 3 states of matter. In gas, molecule have no force of attraction. In liquid, molecule have little force of attraction. In solid, molecules have strong force of attraction. In water molecule, you have seen this molecule is attracted by this molecule. They have little bit of force of attraction in between them. And due to this force of attraction, since they have little bit of force of attraction between the molecules, that's why it exists as liquid. But in case of H2S, there is no force of attraction between the molecules because they cannot form any kind of hydrogen bonding. They have negligible force of attraction in between the molecules. So since they have no force of attraction in between them, it will exist as gas. Have you got it? So if the question asks water is liquid, H2S is gas, explain, then you have to write like this: water molecule can form intermolecular hydrogen bonding, and due to formation of hydrogen bonding, molecules have some force of attraction in between them, and that is why they exist as liquid. But in case of H2S, the molecules have no force of attraction in between them, and that is why it exists as gas, like that. So this is another application. Whether the molecule will exist as solid, liquid or gas, you can explain it by applying the concept of hydrogen bonding. See, as I have told you, the orthonitrophenol, 2-nitrophenol, it can form intramolecular hydrogen bonding, and paranitrophenol, 4-nitrophenol, already I have shown, it can form intermolecular hydrogen bonding like this. This is NO2. So in between them, they can form hydrogen bonding between delta plus and delta minus. Delta plus, this is delta minus oxygen, hydrogen delta plus. So they can form. What is the difference? This is called intramolecular hydrogen bonding, and this is called intermolecular hydrogen bonding. Now, see, here within the molecule bonding takes place, here in between the molecule bonding takes place. When within the molecule bonding takes place, no association takes place here, but here association of molecules takes place. So that is why, although their formulas are same, although their masses are same, 2-nitrophenol and 4-nitrophenol, but boiling point you will get different. This one, paranitrophenol, have more boiling point than this orthonitrophenol. Why? It is due to formation of intermolecular hydrogen bonding. Due to formation of intermolecular hydrogen bonding, association of molecules takes place, and that's why overall mass going on increasing. But here, no such association takes place. Within the single molecule bonding is formed. That's why mass will remain same. Ultimately, boiling point you will get less. So orthonitrophenol and paranitrophenol, although they have similar mass, similar formula, but their properties are different. So their boiling points are different due to formation of this intra and intermolecular hydrogen bonding. And there are another application also. If you want to explain why ice floats over water, you know ice always floats over water, na? Then also you can apply the concept of hydrogen bonding. In book you can see these explanations are given. So there are number of reasoning questions in which you can apply the concept of hydrogen bonding. Similarly, I want to tell you another application. You know organic compound, I have shown earlier, alcohol can form hydrogen bonding with water molecule. I have shown the hydrogen bonding. Those organic compounds which can form hydrogen bonding with water, they will always be soluble in water. And those organic compounds which cannot form hydrogen bonding with water, they become insoluble. For example, alcohol can form hydrogen bonding with water molecule, and that's why alcohols are soluble in water. But the same organic compound, if you apply, suppose alkane cannot form hydrogen bonding with water, because alkane do not contain any electronegative atom, and that is why alkane cannot form hydrogen bonding with water. And since alkane cannot form hydrogen bonding with water, and that is why alkanes are insoluble in water. So this is another application for hydrogen bonding, whether an organic compound will be soluble in water or not. Then also you can apply the concept of hydrogen bonding. Those organic compounds which can form hydrogen bonding with water, they always be soluble in water. So these are some applications of hydrogen bonding I have given. Number of applications are given in your book. You read the book, then you can understand about this topic. Thank you.